Okay, Dr. Marin Roberto, thanks for your invitation to invite me to attend for this conference event. Today my talk is on the GIS-based tool for probabilistic physical modeling and prediction of landslides. Of which the aim is to introduce GIS-FORM landslide toolbox that developed by my research group. And before the presentation, give some little words about myself. My name is Jian Ji, and I'm a professor of geotechnical research, geotechnical engineering at the Hongzhi University in Nanjing City, China. And now I'm hold the professorship level position in my school, and my research is mainly focused on some aspects of geotechnical engineering, which includes the slope stability analysis, landslide susceptibility mapping, and also some some geotechnical reliability analysis with probabilistic modeling. So, okay, that's just a little words about myself. I hope we can have some more chance to, for some research or conference meeting at other place. So my topic actually for today is originated from a published paper that just in this year, earlier this year, we published our work on the journal Landslides, and this is the some details of our publication. And I'm very glad to say that since the online release of our paper, it has been attracting a lot of attentions worldwide, right? So for this paper, based on that paper, my topic for today is the contents of my topic will be some very some very summarized contents. I will give some research background. Let's look at China's geological hazards, status, current status. So 2 years ago, in 2020, there is the survey of geological hazards in China that happened summarized by the BRC, and a lot of geological disaster in China, because this is a map of China, and especially for some places in the middle or western parts of China, a lot of mountain areas. So geological hazards happen mostly on this area. And we have, as summarized or reported, figures said we have, 7,000, more than 7,000 geological disaster sites in that area, including many deaths and missing people, and also some of the injuries and economic loss, accounting for around 5 billion yuan in renminbi yuan. And this is the there's in recorded data of China geological disasters for the last decades without any without any surprise. The landslide is the first place. Takes first place for the amount of disasters. So for the landslide, we we have a better understanding that the most important triggering factors are earthquakes and extreme weather, like the rainfall, heavy rainfall, right? And the research interest on those aspects are continuing to increase in China and also worldwide. But for landslide prediction, the major objective is to produce some easy to follow or understand, easy to interpretation data or outputs, like the susceptibility assessment. We use the regional landslide susceptibility assessment for landslide planning or disaster mitigation, right? So, but for this work, the purpose is to roughly to estimate the failure probability for the region of interest. This is the actually what we call the landslide hazard susceptibility zoning map. I believe all the audience, most of our audience are experts in this field, so they are not it's not common to understand. So, but for some basic concepts about the regional landslide hazard mapping is actually, well, we start with individual landslide analysis, which is typically known in geotechnical engineering for slope stability analysis. But for actually for slope stability analysis, that is a good topic, a very in the most important topic in geotechnical engineering, and we have a lot of methods to do the slope stability analysis, like the limit equilibrium analysis, finite element analysis, and some others. But actually, for the landslide mapping for the regional area, it involves a lot of repeated calculations for such aspect, and we commonly adopt to some simple model like this is kind of an infinite slope model, which are sufficient for our landslide mapping, hazard mapping. And for the regional landslides analysis, we except for the slope stability model, right? It's stability model, easy to follow stability models. We also need some additional information like the geography, geological information, and even the regional rainfall data, right, etc. And as to say the regional landslides, the area is very wide, and it can involve a lot of unknown parameters, especially for the geotechnical parameter, right? Soil parameter, shear strength, soil shear strength, like rainfall, infiltration, etc. For those kind of geotechnical parameters, they actually by nature show some uncertainty from site to site. So that is called the uncertainty of geotechnical parameters, which are important for our understanding, accurate understanding of the regional landslides. And the purpose of our work is to develop a probability analysis tool to predict the regional landslide failure probability. Right. For that work, in the literature, we have two types of the methods, like the data-driven, right? Based on the data, historical data, we can regress some formula to be used for the regional and landslide mapping. And the second type is the physical modeling. Myself is also focused on physical modeling analysis. And I believe some other researchers, like some speakers in yesterday, the day one of our conference, and also Dr. Marin, yourself, right, is an expert in probability physical modeling. And for the first half, the statistical regression analysis, they have some advantages like the rapid assessment, but it entirely relies on historical data. So by itself, it has some disadvantages, which include the lack of generality, because sometimes it can be overfitting method, and ignoring the intrinsic damage mechanism of landslides. And also it lacking analogous historical data or small data. If in this condition, our the landslide mapping could be not adaptable. So for the physical modeling, we can fully consider this stability model, right? Slope stability model, giving the geographical information, and we can take full account of real slope information like this, and also the soil mechanical properties into account. And also versatile landslide mechanical analysis we can include, or we can adapt to different stability models, and a quantitative evaluation can be made for specific areas in the absence of historical data. So that is some advantages of the so-called probabilistic physical modeling, but also is subject to some disadvantages, unluckily, right? So like for example, for each cell, calculation cell or grid or in the region, right? We have to carry out individual slope stability analysis by the probabilistic physical modeling. And also for some large areas in the region, it can producing the hazard mapping could be time consuming if we use a very high resolution of the mapping, right? And the feasibility of probability physical modeling is that feasible for landslide mapping. So to do that work, we have to change the conventional way of the probability physical modeling using the geotechnical reliability method. So that's I'm sorry that the time is very fast, so I have to go a little bit quick of my research work, right? So and also the regional hazard prediction, we have some existing problems, right? Like we have some difficulty to implement the probabilistic methods. Yesterday, I think another researcher already presented his work based on the Monte Carlo simulation to account for the landslide mapping, accounting for soil uncertainties. And also there's some other alternative methods for the probability methods, like the first order method, first order reliability method, etc. So this is the focus of our work is to use the first order reliability method to produce the probabilistic realization in order to produce the failure probability in the region, landslide region, right? So let's look at our developed tool, the so-called the GIS-FORM toolbox for the which is based on GIS platform to produce or to realize the probabilistic physical modeling. For the geotechnical reliability methods that as the basis of our algorithm is so-called the first order reliability method for geotechnical reliability analysis. And this is the concept of probability of failure calculation. Actually, the purpose is to propagate the uncertainty of your input parameters to the results, right? The results can be the factor safety, mostly the factor safety for our landslide prediction. So for this purpose, we have the Monte Carlo simulation, right, method, as I just now briefly introduced, and also the some numerical methods. Like the numerical method is to it's not to use the computer simulation, right? Repeated simulation, but on the other hand, use some numerical tools to approximate the failure probability, and that is our work. And we developed a new concept for the iterative algorithm based on the HLF, Haskell-Lin Rank-Way Fissler, which is a sub-algorithm of the first-order reliability. And we developed this iterative algorithm in the original space of random variables, resulting to our efficient algorithm called the HLF. X in the X space means the original random variable space. Either your random variable is in normal, log normal, or correlated log normal, etc. We can consider the full statistics over all the random variables. So that is the advantage of our method. And we have some research basis and some previous publication on this topic. Interested readers, interested audience can refer to our work, previous work. And so regarding the implementation of the first order reliability methods in GIS platform, so this is the overview of the toolbox, how we develop our toolbox and the workflow, including the inputs, by looking at the original DEM information, DEM, right? DEM DEM information and the geological map, coefficient like soil coefficients, and some statistical information of the geotechnical parameters, and also we trying to use the parsing. It's called the NumPy integrated into with the ArcGIS. The output will be, by using our algorithm, the first order reliability algorithm, we can produce the reliability index instead of the failure probability, and then we convert the reliability index into the failure probability, which is the basis for hazard mapping, landslide hazard mapping. We can mapping for the factor safety, displacement, in terms of the seismic analysis, and also the failure probability of the regional landslides. And this is the algorithm flow chart, right, for the F1 first order reliability. And it roughly is based on iterative calculation, but the convergence is very fast, only 2 or 3 steps, iterative steps to achieve the converged results. So that is this is the toolbox interface, right? How we implement our methods and the inputs of all the necessary data, and also the choice of computational methods, and we can produce the reliability, or on the other hand, some failure probability to produce the hazard susceptibility hazard mapping, right? And the method including some well-known in terms of seismic analysis, we included some calculation models for the displacement, hazard displacements, seismic displacement, etc. And let's look at our method feasibility and some validation. So this is the inputs. As an example, we use some of the soil we consider some of the soil parameters to be on certain random variables. They follow some statistical distribution like normal distribution, or including the mean with the mean value and the standard deviations of each of the parameter, and also the statistical distribution. These usually are some basic basic information for the full stability, full statistics. And also some the stability model in terms of the factor safety formula. We use this formula, which was previously reported by another research group and published just last year. Right, this is the implementation, effective implementation results. We, for example, the landslide mapping, we consider those kind of this number of grid points, and the calculation time, the cost of the calculation is around 15 minutes. 15 minutes for this big number of grids. but I think this is a very sound, reasonable, calculation cost. And here are some results, and we do some comparison between our proposed method GIS-FORM with literaturely reported method, so-called GIS-TISA. GIS-TISA. So by comparison between the proposed method and the others, we can say mostly for simple conditions, the results are very comparable. Either in terms of the fatal safety or the some seismic acceleration for seismic earthquake based landslide analysis, and also for the hazard mapping. Hazard mapping, we are more interested in the failure probability, right? Failure probability for the simple working condition like the soil properties. Uncertainty, but just considered with very simple condition like independent of each other of the soil property, and also simply follow the normal distribution. The methods comparison between our methods and the literature very agrees very well. So it proves our method is fundamentally correct and acceptable. But for some complex working conditions, like if your soil parameters are correlated, some of the soil, like the soil shear strength, some of the soil strength, they have some correlation, right? So we consider correlation between the soil shear strength, and also we can consider the some non-normal distribution, like the log normal distribution, or some other beta distribution, or some other some complicated distributions, static distributions. In those complex working conditions, our proposed GIS-FORM toolbox still works, but for the GIS-TISA, like some other simple reliability methods based platform or toolbox, they cannot do that work. So, and also we show the effectiveness over our original landslide hazard mapping by the proposed GIS-FORM. Those are example, worked example, right? So the zoning, the level of zoning by differentiated the failure probability are shown here, right? Like our failure probability, the threat of failure probability, 5% or 10%, we corresponding to low failure probability, very low, medium, and high, etc. So the effect or the overall effects of the mapping, hazard mapping by the GIS-FORM toolbox, it can, as shown in this figure, very interesting and sound results. Comparison by the two methods and are also shown here, which can say our method really can produce a little bit small failure probability compared with the first or the second moment. And this is the comparison between the two methods also in terms of the fatal safety, very good results, and each produce simply produce the same hazard mapping, because the fatal safety does not involve any uncertainty. So the two methods works equally good. And but for a reliability index, which we may modeling the soil uncertainty and also the distribution correlation, etc. In this type, in this condition, our proposed GIS-FORM looks better, right, than some existing simple reliability methods. And also the failure probability, comparison between the failure probability, right? And this is the example landslide hazard mapping, and the resolution of this example, right? is 247,000 grid units, and the cost of the analysis is around also 15 minutes. So this let's also look at the case application. This is a real landslide events that taking place in 3 years ago or 4 years ago, right? In China, Jiudaigou, in the magnitude 7 earthquake caused a landslide, the regional landslide in the area. And this is a data record, recorded the landslide size in that Jiudaigou area. And here we have some reported data for the hazards, for the earthquake PGA, etc. Right, and also we have the local lithological information. And by that, from that literature, reported literature, we can assign the appropriate soil properties to each of the bedrock, different bedrock, and those are the parameters used for our analysis. And this slide roughly presents the susceptibility mapping of the Jiudaigou landslides. And also we show the influence. We present the influence of. We study the influence of some parameters on the hazard mapping in terms of the failure probability, different probabilities. Right. We study the influence of the soil property variation in terms of the coefficient variation of the soil parameters. Right. They're corresponding to low, very low, medium, and high variation of the soil property. And we present the mapping, different mappings, comparison between the different mappings. Here is also a comparison between the mapping results. It's interesting to point out that the failure probability or in the mapping when you consider a higher coefficient variation for the soil properties, which is around 0.3 for the soil properties, and we can produce very good consistent results for the prediction and predicted failure probability, zoning failure probability, and also the observed between the observed true landslides events. And this is the POD curve made for the Jiudaigou landslides. And we can, using the probability of the probability detection curve, we can quantitatively compare to study the soil property, soil shear strength variation, how the variation of the soil shear strength can affect our the probability detection curve. In other words, when your soil shear strength is around 0.3 of the coefficient variation, which is a reasonable number for the geotechnical in geotechnical engineering, then we can achieve a very good POD curve for our case study. And in the next few slides, we have some unpublished works, but due to the time limitation, we are not going to present all the details. So those will be the rainfall reduced modeling by the GIS-FORM toolbox. And maybe I just jump to the conclusion of my presentation for today. So this study takes the probabilistic reliability analysis algorithm driven by the physical model as a core, and which is embedded into the ArcGIS platform. And we can realize the rapid evaluation of regional landslides automatically and completed by considering some factors induced by earthquake and also the rainfall. But for this part, the latter part is still ongoing and unpublished work. And I think these results can provide a certain reference for the prediction and prevention of geological disasters. Using our developed toolbox, we can use that toolbox, very simple to easy to follow and easy to implement. We can achieve reasonable results for the regional landslides mapping. And some reference of our work can interest the audience can look at our published work, previously published works. Okay, I think I have to end up my talk. Rob too.